Okay, so this stator here, this is outer part of the motor. So this outer part of the motor is called stator. What are the different component of this stator? There is a frame, okay, and we are using core, okay, and we are using winding, okay. So we are using winding for this stator, okay. So what are the different component for this stator? First one is a frame which is connected outside to the rotor. Second part is a core, and different part of this rotor. Or two type of rotors are there. So what are those two types? Squirrel cage rotor, yes, you are right. And second one, first one explained as squirrel cage. Squirrel cage. And second one is, let's explain these terms again. So when you see in this diagram, so from this diagram you can see that stator is a stationary part because it is fixed from these groups, okay, and a rotor is a rotating part, okay, and the speed of this rotor depend upon this expression, okay. So ns is equal to 120 f divided by p, okay. Here ns is the speed of the rotor, f is the frequency, and p is the number of poles, okay. When you increase the number of poles, then what happen? Speed will increase or decrease. Write in chat box. If you increase the number of poles, then what happen? Decrease. Yes. When number of poles are less, then speed is more. When number of poles are more, then speed is less. Okay. So you can see we have connected this stator with frame. In this stator frame, we have placed some terminal boxes, and inside these cores we have ventilating ducts, okay? And the material for this uh, induction motor is mixture of metals, okay, with high graded alloy steel lamination is provided, okay. So how we can use this stator and rotor part? In the last session some students are not able to. So as you can see, so using this electromagnetic induction, these here is the expression. This is the rotor speed. This is the rotor speed. Okay. If we consider this case, there are three cases for this. If this rotor speed, no current will be generated at this stage. So when ns is equal to your rotor speed, then there is no EMF produced right here, and no current is going to be produced. Okay. So this is the next process. Here this rotor speed is less than the ns, okay. So as you can see, this slip is going to be calculated. So we will explain these all expression in detail when we discuss the derivation part for this three-phase induction motor. Right now you understand how this three-phase induction motor is working, okay. So you can see from here that how this rotor speed will be vary with the help of this ns. Ns is the for rotor speed, okay. Here, so This is the stator and rotor part and how it works. We have explained. So now let us understand this stator part. Okay. So you can see from this figure that in the stator there are some slots present. Okay. So in these slots we have to place some bindings. Okay. So these rotors are of two types, squirrel cage and phase wound rotors. And in this squirrel cage rotor, we have explained this in the last session that how we are going to connect these conductors. Okay. So we have number of strips like this. So there is a strips like this. Okay. So we place some grooves across these bindings right here. Okay, so these are n number of plates, n number. They are joined with some insulation. When we have seen the transformer, so how you are going to connect the number of plates? There are number of plates in transformer, and these number of plates will be connected with each other with some insulating material. Okay, so when they join together, they make a transformer like this. Okay. So in this squirrel cage rotor, there are number of metal plates. So these metal plates are joined together with some insulation. Okay. And they form a conductor like this. Okay. So there is a strips inside these strips. We have to place some binding. Okay. As you can see, we have a core and these number of plates are as a conductor. Okay, act as a conductor. Okay, so inside these grooves we have to place some copper winding. Okay, and this is a shaft. Okay, parallel to the shaft. Okay, so when there is a simple principle for working for this. When you place some current carrying conductor inside a magnetic field, that produces force. Okay, so uniform torque will be generated and low locking tendency is generated in this squirrel cage rotor. Okay, so how this rotor will work, we will explain right here. The next type of this rotor is a phase wound rotor. What is the difference between phase wound and squirrel cage? From here you can see what is the locking tendency. Locking tendency is nothing but when your ns is equal to your speed of the rotor. No current is flowing. No current is flowing. Okay. So when they are in the same position, then no EMF and no current is going to be generated. Okay. Okay. So this is the locking tendency right here. Now, this is the second type we have explained in the last session. This is a phase wound rotor. In this phase wound rotor, all the steps are similar. We have placed these conductors right here. Okay, inside these conductor we place some binding. Okay, and the main difference is this one. We are going to connect right here brushes and slip ring. With the help of these slip ring and brushes, you can control the speed of the motor. And these brushes and slip rings are connected with two connections. One is a delta connection, another one is a star connection. Okay. So Pankaj Singh is saying that, sir, what is NS? So we have explained that how this NS is going to depend. NS is directly proportional, inversely proportional to pole. Okay, so this synchronous speed, Gautam is saying synchronizing speed. Okay, so if your number of pole, have you understand this equation? Ns is inversely proportional to number of poles. Gautam is saying it is synchronous speed. How to achieve the synchronous speed of the motor? So Pankaj is saying voice is lagging. So is it clear now? Okay, so Pankaj is saying it is clear now. Okay, so Ns is the synchronous speed. How to achieve this synchronous speed? We have seen from the previous example, when this synchronous speed is equal to the speed of the rotor, okay, then there is no EMF and no current, then this locking tendency will achieve. So this is the synchronous speed, okay. So it depends upon the slip. Okay, S is the slip. We will discuss these terms in later section where we are going to derive the slip, what is slip and what is the speed of the motor in the different three cases. Okay, we will explain in detail when we derive the expression for this okay, synchronous speed. Okay, so now right now you understand the construction of this uh, three-phase induction motor. Pankaj, Toshiba, okay, Gautam, clear? Any doubt till now? Write in chat box how we are going to construct a three-phase induction motor. Okay. So right now we are studying how to find different part of induction motor. Okay. So we have seen that these conductors are connected in this rotor part, okay, and in these conductor there are some grooves. Inside those grooves we have to place some winding, okay, and in the shaft there are two positions for slip ring and brushes, and these slip ring and brushes are connected toward the delta connection and the star connection. So with the help of these delta and star connection, we can increase the speed of the rotor and we can decrease the speed of the rotor. Okay. So understand till now how we are going to construct a three-phase induction motor. Write in chat box. So understand this. I will explain again. I will revise these all sections again. Okay. So from here you can see that stator is a stationary part. Okay, it consists of outer frame, stator core, stator winding. Okay, so what is outer frame? Outer part of the three-phase induction motor. Okay, it support stator core, protect inner parts. Okay, what is the stator core? The stator core is to carry the alternating magnetic fields, okay, which produce hysteresis and eddy current loss. So how to reduce this eddy current loss and this hysteresis loss? So we have to connect these rotors like this, okay. If we have number of rotors and we cut these number of rotors plates and we join these number of rotor plate with the help of some insulation, then we can reduce the hysteresis and eddy current losses. To reduce the eddy current loss and the hysteresis loss, they are connected with some insulation. Okay, understood? Here, then what is stator winding? The stator core carries a three-phase winding. What is a three-phase? We have explained in the video that one phase start from this position, another phase start from this position, okay, and third phase start from this position. So these are three phases. This is first phase, this is second phase, this is third phase. So how many angle for each phases? So we have seen in the last sessions that each phase differentiate with 120-degree angle. Okay, understood? Clear? So this is the phase number 1, this is phase number 2, and this is phase number 3. Okay, and now squirrel cage and phase wound rotor. A squirrel cage rotor consists of laminated cylindrical core having semi-closed circular slots. Okay, and copper or aluminum bar conductor are placed inside these slots. Okay, and short circuited to each others by copper and aluminum rings. Here, next is phase wound rotor. So in this phase wound rotor, we use slip ring and brushes. Okay, so slip ring rotor consists of laminated cylindrical core having semi-enclosed slots at the outer peripheral and carries a three-phase insulating winding. Okay, the rotor is wound for the same number of poles as that of the stator. So till now, have you understood how we are constructing three-phase induction motor? Write in chat box. Quickly give your response. Till now, have you understood? Quickly give your response. Okay. Okay. So now we will cover these principles, how this rotor will move. Then we cover how rotor speed will vary. Okay, how the angle of this rotor will change, how this slip is going to affect on this three-phase induction motor, what are the different expression for these slips. Okay, so these are the number of points we will discuss in this section. And today we have one more lecture in the evening. Okay, so we will cover all these points. Okay, let's understand the basics, how the rotation of this rotor, okay, will work. Okay, so let's understand from here. We have three phases. This is first phase in red, second in blue, and third in yellow. Okay, so right now you can see we have different winding and we have different poles connected together. So you can see from here this red phase is generated from these two conductors, okay, and we have placed two winding right here. A and A dash is the first phase, second is a blue. So these two conductors are placed right here. So B and B dash is the second phase from this conductor, okay, and third phase is from C and C dash. You can see from here, okay. So in the third phase, you can generate B and B dash phase. So any doubt regarding the phase generation of this rotor part? Write in chat box. How the phase of this winding will be generated when you place these winding across this conductor? Write in chat box. Quickly give your response. Quickly give your response. Have you understood how these three phases will be generated? Repeat. Okay. Okay. So I will repeat this. So three-phase supply is applied to the stator. Okay. So this three-phase current will flow through the three coils and produce their own magnetic fields. Okay. positive half cycle of the AC current, find out this inside this winding right here. Okay, inside this rotor there is a winding. Okay, inside this rotor these three phases are going to be generated. So how you can generate these three phases? We have number of poles. Okay, so this is one pole, this is second pole, this is third, fourth, fifth, and sixth. You can connect n number of poles. If number of poles are increased, your speed will be vary according to number of poles. Okay, so if you place four number of poles, it depend upon ns synchronous speed will be depend upon these number of poles. Okay, so we have connected six poles right here. So this is first pole, then second, third, fourth, fifth, and sixth. Okay, across these six poles, we have connected three phase winding. So this is the one phase A, and A dash is the first phase. Second B and B dash is the second phase. And third is C and C dash is the third phase. Okay. So when you connect the winding, Pankaj is saying, sir, how speed will decrease by increasing pole? Okay. So we will explain these concepts right from these equations. Okay. How you can increase or decrease the number of poles. Okay. As we can see, this ns is equal to 120 f divided by p. Okay. So p is the number of poles. If you increase the number of poles, then your speed will be decreased. If you increase the number of poles, your synchronous speed will be increased. Okay. Understood? Pankaj, any doubt? Write in chat box. Pankaj, give your response. ns is inversely proportional to number of poles. Yes, Toshiba. So that's why this is the expression. If you increase the number of poles, this will decrease. If you decrease this, then it will increase. Pankaj, understood? Okay. So let's understand this again. We have a stator winding like here. How you can connect this winding? Let's suppose this is our outer portion. Okay. In this outer portion, we have to connect number of poles. So there are different number of poles. As we can say, we have six number of poles. Okay. So you can connect six number of poles right here. These are six number of poles. So this outer portion is a stator portion. Inside this we place a rotor part. Okay. So we have to place winding in the stator part. In this we have to place some winding right here. Okay. So we have to place some winding right here, the stator part. Here, any doubt till now? Write in chat box. So let's suppose this is our phase number 1. Okay, this is our phase number 2, and this is our phase number 3. So these phases are generated in the stator part. This is the outer portion. Okay, this is the outer portion. Here we have number of grooves. Inside these grooves we have to place the winding. Okay, so these windings are placed like this. This is A dash. This is B dash. This is C and C dash. Okay, so you can see from here. So inside this we have to place a rotor part. This is the rotor part. Okay, this is rotor. When you give some phases right here, okay, now how you are generating your phases, this is the principle. Write in chat box quickly. Give your response. Have you understood? And we move toward next slide. Okay, so you understood that how we are going to generate the number of phases and what is the difference between these number of phases. Okay, so we have explained earlier also that when these three phases are generated, they are 120-degree apart to each other. Okay, so how you can calculate these angles? How you can calculate these angle? The angle can be calculated using number of phases, total angle divided by number of phases. So 3 is the number of phase and we have 120-degree angle between each phase. So Pankaj is asking a question. More poles pair more phases. More pole, we have a three-phase winding, so only three phases are going to be generated. So that number of poles are different. Okay, in this slide we are discussing that how to generate three phases in the winding. We have only three winding in the three-phase induction motor. So only three phases are going to be generated. Pankaj, write in chat box, understood? Okay. Okay. So any doubt in now? Okay. So now the what is this? Okay. So let's understand this. Three phases are generated. Okay. So let's suppose that we have phase 1, 2, and 3. Okay. Let's suppose that these phases generated by A1, A2. Okay. When your phases like 1, 3 and 2 are generated. Okay, like here A1, A2, this this is the third phase. So C1, C2, then B1, B2. So these phases are reversed right here. Okay, this third phase is generated after first phase. Okay, so the direction of rotation will be changed. You can just change the winding. Okay, when you change the winding, you can change the speed of the motor. Sir, can you show the previous diagram again, Gautam? Okay, so this is our previous diagram. Ask question, Gautam, what you want to ask. In this previous slide, we have seen how the three phases are going to be generated. So Yamini is asking question, what is the difference? How did we change the direction? No, sir, clear. Okay, Yamini. So Yamini is asking how we can change the direction of this motor. So let's understand Yamini from here. We have winding. Okay. So this is the first phase. This is second phase. This is the third phase. Okay. When you change, so Yamini is asking question how the phase will affect the direction of rotation. So in this presentation, we are discussing how these phases are generated. Okay. In the next presentation, right here, we are saying that if you are changing the direction, okay, so if you are changing the phase binding, then our direction is going to be changed. Okay. So how this will happen, let's understand from here. So with the help of this Faraday law, with the help of this Faraday law, you can find out the direction of rotation. Okay. You can in this presentation also how these rotors and stators are connected, how these phases are going to generated. This outer portion is the stator part. So these binding are placed outer side. Okay, so these are placed at the stator part. Okay, so inside this black position is a rotor. Okay, so let's understand from here. This outer part is connected with binding. Okay, so binding is placed outside this, and inside this there is a rotor. Inside rotor there is also some binding are placed. Okay, so when you give the three phases from this stator part, what happened? So you can see from here, when you pass this current carrying, this what is the working principle for this three-phase induction motor? When you place some current carrying conductor across a magnetic field, it generated force. Okay, so here is a magnetic field. Magnetic field is generated right here when this rotor part is a conductor part. Okay, this is a conductor part. When you place a conductor inside the magnetic field, it experiences a force. Okay, so this is the principle applied right here. This is the rotor part. Inside this rotor there is also binding is placed right here, and when this magnetic field is produced across this binding, okay, across this three-phase binding from here, so it experiences a force. Okay. When you apply